Okay, ladies and gentlemen, we get to talk about factoring a difference of squares, and it's just you and me. The class is doing their work already, so we're going to go quickly on this video, and if you need to stop and pause to write in and fill in your notes at any point, you do so, but I'm going to go from the beginning to the end in one shot. Okay, so we're going to look at factoring differences of squares. First of all, what is a difference of squares? The word difference means subtraction. That's the first thing you have to understand. That we're talking about the subtraction of two perfect squares. Think about it like this. I got a square. So this side equals this side. Subtract another square where this side equals this side. And that's really the idea here. You're subtracting a square term by a square term. Now, what do we mean by a square term? Well, if this side length was A, and this was A, and if this side length was B, and this was B, then we could call this area A squared, and we would call this area B squared. And the difference of squares would simply be A squared minus B squared. And that, in fact, is the definition of a difference of squares. You take a value and you square it. You take a value and you square it. And if there's a difference between them, we can factor that. Now, this is brand new. You've never seen this. I'm going to tell you that A squared minus B squared is going to be able to be factored into A minus B, A plus B. Now, I'm going to go farther. I'm going to tell you that A squared minus B squared can be factored into A plus B, or A minus B. And in fact, these two are the exact same. This is A minus B being multiplied by A plus B. This is A plus B being multiplied by A minus B. The order of multiplication does not matter. Let's think about that. What's 5 times 2? It's 10. And what's 2 times 5? It too is 10. The order that I write the 5 and the 2 does not matter for multiplication. So the order that I put the A minus B term or the A plus B term does not matter. So back to the question. A brand new concept, new idea for you. A squared minus B squared can be factored into A minus B, A plus B. And that's called factoring. And what you're doing is you're taking an expanded polynomial and you're putting it into its factors. So this times this gives me this. And if I went the other way, that's called expanding. So what we're doing for this lesson and the next few lessons is the opposite of the distributive property, the opposite of expanding. You're going to take a polynomial and put it into things that multiply together to give that polynomial. So, I'm going to prove something to you. I'm going to start with A minus B, A plus B. And I'm going to prove to you that it actually does equal this. How am I going to do that? By expanding it. A times A is A squared. A times B is plus AB. Negative B times A is negative BA, and negative B times B is negative B squared. Now, these two, this is A times B, this is B times A. The order of multiplication does not matter. So, I can write it as the same. This is the same as that. Now, once I do that, and I start looking at collecting like terms, I've got a positive AB, and I've got a negative AB. They're going to go together to give me no more ABs. They're gone, which leaves me with A squared minus B squared, which is what I told you I was going to prove. Well, let's do that one more time, just so that you see it. Let's go A plus B this time, A minus B. A times A is A squared minus AB plus AB minus B squared. If I have a minus AB and a plus AB, that's going to be no more ABs, and it's going to leave me with A squared minus B squared. So once again, I am proving to you that if I have this, it is the same as that, or the same as that. Your choice. But whatever comes first here, comes first here, and comes first here, comes first here, comes first here. And that is a difference of squares factoring. They need to be squares, these terms, and it needs to be subtracting. So, I've basically gone over everything that's written here, except with my own words. You can read through that if you want. That is what you got to remember for the rest of your life. And so, we're going to go through some examples. Now, these first two examples are just getting you ready for recognizing perfect squares. So, this says write the positive square root of each. So we know that the square root of 9 is actually 3. The square root of 25 is 5. The square root of x is x. And the square root of 4x squared is 2x. And what they're really trying to get you to understand with that question, what's important to them really, is that you understand that if I take 3 and square it, I get 9. And if I take 5 and square it, I get 25. And if I take x and square it, well, I get x squared. Go figure. And if I take 2x and square it, I get 2x times 2x, which is 4x squared. That's the important part of that question. Write each number as a power of its positive square root. So 16 is actually 4 squared. 9 is actually 3 squared. And I'm going to put in another one here, c. I'm going to say 4x squared, and I'm going to say the answer is 2x squared. So these are all what you would have to square this to get what's up above. Example 3. Finally, we get to do a real question. Let's remember that a squared minus b squared equals a minus b, a plus b. That's the formula. So when I look at this, what I do is I rewrite the question so it looks like a difference of squares. 25 is 5 squared. So I now know that my a is x and my b is 5. So putting an x minus 5 and an x plus 5. Now you may need to stop the video and go back and do that one more time and think about it. This stuff is not going to come easy. You're going to have to really think about what's going on here. But if we look at this question one more time, what I did was I took this question and I wrote it so I could see it like this. I wanted to be able to see it in that term. So 25, I know, is 5 squared. Now that I've written it in that term, I know that this is equal to a minus b, a plus b. How do I know that? Because I just taught it to you. So this is your a, this is your b, so you end up with x minus 5, x plus 5. And before anybody asks me, yes, that's exactly the same as writing it like that. The order of multiplication does not matter. So the next one, x squared plus 16. I'm going to rewrite it so it looks like a difference of squares. And I notice it can never look like a difference of squares completely because that's not a difference of squares. That's a sum of squares. And we don't know anything about the factoring of a sum of squares. The only thing I've talked to you about is a difference of squares. That's got to be subtraction. So does not factor as a difference of squares. Why not? Because it's not a difference of squares. It's a sum of squares. That's a sum of squares. And I haven't told you anything about those. Okay, next one. 1 minus 49x squared. We need to know that 1 is its own perfect square. 1 squared is 1. Now that might have taken a little bit of thinking, that 49 was 7x squared. You might want to think about that for a minute. If I have 7x squared, it means 7x times 7x. 7 times 7 is 49. X times x is x squared. There it is. I've written it as a difference of squares. I now use my formula. Do we remember what it was? You should write it out a few times so you don't forget. So a squared minus b squared is a minus b, a plus b. So in this case, my a is 1, so it's going to be 1 minus 7x and 1 plus 7x. The thing to be very careful of here is that whatever comes first has to come first there. If you were to write this like this, as 7x minus 1 and 7x plus 1, that would be a big no. That's wrong. It does not work that way. So whatever comes first here comes first here. All right, so 4x squared plus 10. I'm going to try to write it as a difference of squares. So it's 2x squared plus, and 10 doesn't get written as a perfect square. 10's not a perfect square number. And furthermore, that's not a difference of squares. So does not factor as a difference of squares. Why not? Because it's not a difference of squares. First of all, it's not a difference, and second of all, 10 is not a perfect square, so it's not going to work out for me. Let's flip that over, and we go on to example 4. Factor each of the difference of squares and check your answer. So the first one, I'm going to make it x squared minus 6 squared. That's going to be x minus 6, x plus 6. Isn't that great? See how fast that works? No problems at all. Now, if I want to check it, all I have to do is expand it. And if it expands back to what I started with, then I'm good to go. X times x is x squared. X times 6 is 6x, minus 6x, minus 36. If I have positive 6 and negative 6x, I get no more x's. And I end up with x squared minus 36, and it works. Life is grand. Let's do the next one. Change it to a perfect square. So 9 is a perfect square of 3 squared. So now this becomes 3 minus x and 3 plus x. And notice the 3 came first, so the 3 needs to come first here. And I can expand that and get the right answer, but I don't really want to. And I'll do the next one with you instead. So 4x squared minus 81. Oh, sorry, 16x squared. I was getting ahead of myself. That becomes 4x squared minus 9 squared. So 4x minus 9 and 4x plus 9. That's my final answer. If I want to check it, I take my answer, I expand it, so I get 16x squared plus 36x minus 36x minus 81, 16x squared minus 81, and I end up back where I started, so it is correct. Last one, 4x squared minus 1, change it into difference of squares, so it looks like a difference of squares. Remembering that 1 is its own perfect square, so it's 2x minus 1 and 2x plus 1. And again, you can expand that out and get the right answer. Example 5. The area of a $5 bill can be modeled with the expression A equals x squared minus 16 with an area in square meters. Yeah, I don't think so. That's a pretty big $5 bill. How about square centimeters? That's probably closer to the right unit. Find the expression for the length and width. All right, so a $5 bill. That's a rectangle, right? It's going to look like this. We're going to have a length, and we're going to have a width. So far, we know that the area is equal to x squared minus 16. I need to change that into a length times a width. So I got to get two things multiplied. To do that, I'm going to factor this. So it's x squared minus 4 squared, which is x minus 4, x plus 4. So I've just taken my area and I've factored it with the variable x into two things that multiply to give the area. One of them's the length and one of them's the width. Now normally you have the length the longest one. So this one should be x plus 4. Now that's normally, it's not always the case, but usually. And the width is going to be x minus 4. So there's your length and there's your width. Use your answer from A to find the area of the bill when we give a value for x of 15 centimeters. Well, we knew this. That was the question. In part A, we figured out this. And now they're asking for this. So they want you to put 15 in for x in your answer for part A. So it's 15 minus 4. 15 plus 4, that'll be 11 times 19, which is 209 centimeters squared. The next question says, check your answer in part B, so this answer, by substituting the value of x equals 15, into the original this time. So ax in the original is x squared minus 16. A of 15 in this case is 15 squared minus 16. I think that's 225 minus 16, which is 209 centimeters squared. And what we found is that this answer equals this answer, so it doesn't matter if x equals 15, whether we use area equals x squared minus 16, or if we use x minus 4, x plus 4. Both of them will give us the same answer of 209 centimeters when x equals 15. Centimeters squared, sorry. Meaning that the two forms are identical. You got some homework here from your textbook. I'd like it done, please, and I think I'm going to ask you to submit it, so do it nice and be able to take a picture of it and upload it, and we'll be back in a few minutes.